Hi guys, this is a calculus video 7-6 for Wednesday, February 1st. No, that doesn't sound right. That would be March 1st, right? March 1st. Yes. And there's going to be no homework to go along with this. So we're going to do an AP calculus problem together. So this was from the free response section 2004. And so they say consider the differential equation right here. Okay, so dy dx depends both on x and y here. On the axes provided, sketch the slope field for the given differential equation at the 12 points indicated. So we're going to need three columns, an x column, a y column, and a dy dx column. So over here, and you'll probably have more room than this on the actual test. Okay. So x, y, dy, dx. So that'll be the slope. And okay, so we'll have x coordinates of -1. And for an x coordinate of -1, we'll have 1, 2, 3, 4 corresponding y coordinates. So we'll have -1, -1, -1, -1. And then for x coordinates of 0, we'll have 4 corresponding y coordinates. So 0, 0, 0, 0. And for x coordinates of 1, also 4 corresponding y coordinates. Okay, now I'm going to go like this. Okay. So the corresponding y coordinates are all going 0, 1, 2, 3. Okay, so 0, 1, 2, 3, and then again 0, 1, 2, 3, 0, 1, 2, 3. Okay, and to get the corresponding slope, so at the point -1, 0, we're going to have a slope of what we get when we plug -1 in for x and 0 in for y. Okay, so if -1 goes in for x and 0 goes in for y, we end up with a slope of -2. If -1 goes in for x and 1 goes in for y, we get a slope of -1. And I already did this, so let me look, make sure I'm doing it right. Yeah. If -1 goes in for x and 2 goes in for y, we get dy dx equal to 0. -1 goes in for x, 3 goes in for y, -1, right? Nope, +1. 0, 0, we get -2 for dy dx. 0, 1, wait. No, we get 0. So these are all going to be zeros. Yeah, if x is 0, this whole thing is 0. And then 1 goes in for x, 0 goes in for y, -2. Okay, at 1, 1, we get -1. At 1, 2, we get 0. And at 1, 3, we get 1. Okay, so, alrighty, so I know at the x coordinate 0, these are all going to be 0 slopes. So a little horizontal line at all of these. Okay, and any other zeros, because that's pretty easy. Yeah, at -1, 2, and at 1, 2. So actually this horizontal line also will have a row of horizontal segments. Okay. Now at -1, 0, I'll have a slope of -2. So -1, 0, I'll have a slope of -2. Anywhere else a slope of -2? At 1, 0. So I'll have slopes of -2 here. So let me see. 1, 2, 3. Okay, so that's a slope of -2, and then I'm just going to move it to that point there. All right, and then I'm just going to, whoopsie, sorry. And I'm just not going to tilt this and I'll move it there. Okay, slopes of -2. And then I'll have a slope of -1 at -1, -1. So -1, -1. Wait, sorry. At -1, 1. -1, 1, I'll have a slope of -1. So this is a slope of -1 right there. Anywhere else a slope of -1 at 1, 1. At 1, 1, a slope of -1. You could do this however you want, guys. It's easier for me to take care of the slopes that are the same at the same time. And now I only have these two left, and the slope for those is +1. Okay, so +1. +1. Okay, so we just earned 2 points. Okay, so I'm looking at the grading rubric here. We earned 2 points for this. And you would have gotten just a single point if you got the 0 slope at each point x, y, where x is 0 or y is 2. So just 1 point for getting these slopes and those slopes. All the horizontal slopes, getting those would just give you 1 point. And then getting the other slopes would give you the second point. Okay, so that's not bad, 2 points on that. While the slope field in part A is drawn at only 12 points, it is defined at every point in the xy plane. Describe all points in the xy plane for which the slopes are negative. Okay, so just looking at the slope field, I see that my negative slopes, I've got slopes of 0 here and here. I've got positive slopes there, and I've got negative slopes at these points. Now looking at my slope field, how could I describe these points? They are below the line y equals 2, and they are to the left and right of the line x equals 0. Okay, so that's one way that you could describe it. But let me look at the equation, because this'll help us. When is this negative? Okay, x cannot be 0. All right, so we're on part B. So x cannot be 0 because if x were 0, then we would just end up with 0, all right? And no matter what, guys, this part is going to be positive, all right? So this part will be, for any x we plug in, we're going to get a positive number there. So whether this is positive or negative depends on this factor giving us a negative output. All right, and this is going to be negative, so y minus 2 is less than 0 for y is less than +2, all right? So if y is less than +2, then we'd end up with a positive times a negative, which would give us a negative slope. So x can't be 0, and y less than 2. Okay, and I'll just say slopes would be negative for all points x, y with these conditions. All right? And then let's see what they said. Yeah, they said slopes are negative at points x, y, where x is not equal to 0 and y is less than 2. And you would just get 1 point for this. Okay, 1 point for the description. Okay, now part C. Find the particular solution, y equals f of x. So right here, guys, they're telling us that they want us to solve for y. All right, sometimes you don't have to solve for y when you're finding the solution to a differential equation. Find the particular solution in this form, y equals f of x, to the given differential equation with the initial condition f of 0 equals 0. All right, so here's our differential equation. The first step in solving it is to find the general solution, and then we'll use this initial condition to find the particular one. But to find the general solution, we have to separate the variables. So I'm going to multiply both sides by dx, and I end up with dy equals x to the 4th y minus 2 dx. Then I have to separate the variables. So I'm going to divide both sides by y minus 2. So I end up with 1 over y minus 2 dy equals x to the 4th dx. So we have separated the variables, step 1. Step 2 is to take the antiderivative of both sides. Now guys, notice if you're taking the antiderivative of a quotient, of a fraction, and the degree of the numerator is less than the degree of the denominator, then off to the side, I'm going to go like this. I'm going to let f equal y minus 2. And in that case, f prime is 1. So this is actually of the form f prime over f. And the way you take the antiderivative of a fraction of the form f prime over f is you just do the natural log of the absolute value of the denominator. So this is the antiderivative of the left side, equals antiderivative of the right side is 1/5 x to the 5th plus c. Okay. Now, I think, okay. Now at this point, I'm going to convert from logarithmic to exponential form, okay? And when I do that, actually let me think, what would be easier for us? Okay, I actually think it'd be easier right now to solve for C. Okay, let me try this, guys. Actually, let me try this off to the side real quick, sorry. Let me think. Okay, never mind. I'll just do it how they did it. Okay, so this is going to be E. All right, so I'll have absolute value of y minus 2 equals E to the 1/5 x to the 5th plus C. All right, but guys, this is equal to the absolute value of y minus 2. And then, or this equation is the same as e to the 1/5 x to the 5th times e to the c. Okay? Now, e to the c is this is just a constant. This is just a constant. So, I'm going to call it k. Constant, let it equal k. All right, and now over here, we will end up with absolute value of y minus 2 equals, I'm going to bring the k out front, k which was just e to the c. It's just some constant. It could be anything depending on what c is. 1/5 x to the 5th. Okay. And now, let me get y by itself. Okay, so we end up with y minus 2 equals plus or minus k e to the 1/5 x to the 5th. Okay. And so y is equal to plus or minus k e to the 1/5 x to the 5th. We have to review how to solve equations like this. Plus 2. Okay, now this initial condition f of 0 equals 0, that's going to tell me what this k is right here. Okay, so y, and I don't actually even really need that plus or minus because k could be any number. It could be positive or negative. So if I plug 0 in for x and 0 in for y, I get 0 equals, and let me get rid of that plus or minus. All right, because k, shoot, actually, k is e to the c. Yeah, maybe I should have had plus or minus. Because e to the c would be positive anyway. All right, I promise we'll go over this in class, guys. Okay, so 0 equals plus or minus k. E to the 0 is just 1, so plus 2. Then k equals negative 2. Yeah, so I guess k would be negative. Yeah, so, okay, I'll talk about this in class. Darn it, I don't want to do another video, though. I promise I'll talk about it in class. So we've got y is equal to negative 2e to the 1/5 x to the 5th plus 2. All right, sorry, guys, that I botched that up at the end. But... okay, if it's unclear, I'll talk about it in class. And so just take a look at the way that they solved it. All right, so that's the way that they solved it. And off to the side, they said that off to the side and just like kept it k. All right, well. Okay, that was 6 points right there. Now, definitely you could have got this point for just separating the variables. I know you could have got the antiderivatives. I know you wouldn't have forgotten the constant of integration. So that's a pretty easy 4 points right there, guys. The tricky part would be using the initial condition and solving for y. And that even, I was a little bit like unsure about how to explain that. So, yeah, so there's that. I will see you soon. Have a good night.